Welcome to the Johnson Space Center for the STS-26 Postflight Crew Press Conference. I'm very pleased to introduce Discovery Crew, led by Captain Rick Houck.
Thanks for coming here today. We sure enjoyed that mission, and we were very pleased to see from the smiles on people's faces when we got back here that just about everybody did. I think it was a great shot in the arm for the agency, and as best I can determine, it was also a good one for the country. We're sure pleased to be the most visible part of that great team effort that involved tens of thousands of people. And to start, we'd like to acknowledge publicly how much we appreciated all the work that went into making this mission such a success. And there are just many, many, many thousands of people out there that put their hearts into it, and it's very gratifying to come back with being able to say that the mission was as successful as it was. Of course, my crew here with me at the table today, Dick Covey, Dave Hilmers, Mike Lounge, and Pinky Nelson. We'd like to get right into the movie. So, Jeff, we can turn down the house lights. We'll go into the movie. This is what it really was all about. Here is the ending of a beautiful mission and bringing the United States back into the manned spaceflight program, and we were very proud to represent the country and to be part of the team. Here we are at Suit Up the morning before we launched. We really didn't think we were going to go. We knew that the winds were such that our pre-programmed profile might cause some problems with the structure, but we said, well, we'll suit up anyhow, and who knows, maybe the winds will get better. There were a large number of folks down there at the Cape. Here are some of them. We certainly appreciated, and I think we could almost palpably feel the support that we had.
It took a great effort on the part of the mission management team to come to all the right decisions, which allowed us to launch on this day, and then some very excellent execution of the flow and the count by the launch control team to get us off on the day that we said we were going to, and not too long after the time we said we were going to go. No matter how many times you ride this rocket, you're always a bit taken back by the ignition of the solid rocket motors. It's quite a ride, as you can expect. This is shown in half speed, which makes it take a lot longer than what it really did, but maybe that's kind of what was going through our minds as we rode through first stage. It seemed like it took a lot longer than it ever did in training. We understand there were a lot of very excited people on the ground when we got off the pad, and then they re-emphasized their excitement once we got to the 2-minute point and the solid rocket boosters separated. Obviously, the first part of the flight, the ride on the solid rocket motors, was a very critical one for this mission. Much of the redesign effort that had gone into the Space Shuttle program had been centered around those boosters, and all indications are to date that those boosters performed exceptionally well. We're interested in the follow-up teardown of the boosters to find out if indeed there are any other deficiencies that we need to look at.
Here you see one of the 65 sunrises that we saw during the 4-day mission. Here we have the payload bay doors open, and that's the first thing we did once safely in orbit, and got busy preparing the TDRS satellite for its deployment from the payload bay. There's Rick at the commander's seat reading a checklist, talking to the ground there on the handheld microphone. Dick going through his checklist, making sure the orbiter is go for deployment, making sure everything was ready. Dave Hilmers back at the payload station, checking the CRT, making sure all the parameters are okay, and controlling the switches that release the mechanisms that hold the payload in the payload bay. It's tilted up here at about 50 degrees prior to deployment from the payload bay. The TDRS tracking and data relay satellite there, the black shape with the booster rocket underneath it. Here I am at the panel on the aft flight deck that had all the switch controls for the tilt-up mechanism, the ordnance arming functions, and the actual switch that you throw to fire pyrotechnic devices that cause the payload to separate from its structure, support structure. When you do that, when I did that, push-off springs activate and push that whole 20-ton stack slowly out of the payload bay at about a half a foot per second.
The whole sequence worked as it was advertised. It had 2 solid rocket burns that got it to geosynchronous altitude, which was its target, within a very precise window. Here's Pinky taking documentation of the deploy, and Rick performing the maneuver to back away from the satellite about 1 minute after deployment. We've heard that the checkout of the satellite is going extremely well. It's about 1/3 of the way into the checkout right now. In fact, this afternoon, a maneuver is going to be completed to stop the drift to the west, and there it will be checked out some more. All the systems seem to be go right now, including the KU band antenna.
A marvelously complex machine that requires coordination of a lot of different organizations to make it work, from the booster through the TDRS upper stage and the flight controllers.
Well, with the satellite out, we got busy on a number of mid-deck experiments we had. This is the protein crystal growth, where we're growing crystals for biomedical samples for research ranging from AIDS to cancer research and a lot in between, a pretty complex experiment.
Another experiment we carried was a student experiment sponsored by Mr. Bruce Lloyd. The idea here was to heat up some titanium wires that are encapsulated in these vacuum tubes beyond their phase transition point to see if on resolidifying the crystal structure is different than might be obtained on Earth, the goal being to develop stronger and more pure samples of that titanium.
We carried 2 different student experiments on board. This is the second one that grew some crystals of lead acetate, crystals that grow to a fairly large size in a short time. It was activated by mixing 2 fluids together, and then right before our eyes we could watch these huge crystals grow. They will be analyzed once they got back on the ground to see if there are any differences between those and earthbound ones.
Here I'm setting up a phase partitioning experiment. Phase partitioning is a method for separating biomedical cells by using 2 different types of liquids. We had a container with 18 chambers that we documented the demixing characteristics of the different types of liquids.
Another engineering evaluation or test that we did was taking pictures of the Earth's limb at sunrise and sunset to measure exactly what the brightness was so that sensors could be built for future satellites.
After the primary payload had been deployed, and we spent much of our time accomplishing Earth observation photography. Now, during the course of our mission, we took over 1,800 70 millimeter photographs of the Earth. We also had about 4,000 feet of 16 millimeter film that we took, much of which was out the window, as you see here, coming across the Middle East. This is always a very important part of our flights to the crew members, because we not only get to look out the window, but we get to document what we see. It turns out that during the course of our flight, it was an unusually clear period across the northern hemisphere, according to those people that are used to looking at space photography. And they're very excited about the photographs that we took. And they've even said that there are things that we've taken pictures of that they haven't seen before, or it's been a long time since they've had a good photograph of them. This data that comes from these photographs is used by a wide spectrum of people, geologists, oceanographers, people who study agricultural trends such as the burning of the equatorial jungles, and people who look at our atmosphere and try to ascertain changes in the atmosphere. Those people are quite excited about what we've seen on these photographs, as they have been on previous space flights. This was an exceptionally good pass over the Hawaiian Islands. We had many opportunities to photograph Hawaii, primarily because of the lighting and the time of day that we launched. We probably saw more of it than we did of the other parts of the United States. The equipment that we use is primarily for Earth observations is a Hasselblad 70 millimeter camera, which you saw Mike there with 50, 100, and 250 millimeter lenses. Volcanology is one of the areas that we're always interested in, photographing from space. This is a pass over to Canary Islands off of the west coast of Africa. They happen to be very clear many of the days that we passed over them. We also had several different attitudes that we had the orbiter in, which let us get this particular, one of those attitudes let us get this pass over the Himalayan mountains looking up into China. This was when the orbiter's nose was pointed to the south.
Here's a shot of mealtime. Meals are always enjoyable. As a social event, we play with our food a little bit like we're supposed to. And just get a chance to discuss what's gone on that day and what's planned for the next day. Here's a target practice with an M&M that's out there in the middle, and I think it's a bullseye. It must have been a fluke because the next shot misses by 3 inches here.
We do carry up with us some photographs of our families. You see them on the lockers to the left. We also, during a period during one day, take some pictures next to some stickers from our alma mater and so on. But you can see we keep a pretty clean cabin.
In the back, you can see the sleep stations that Mike and I used.
Had our own fish bowl here.
We had eaten most of the fish by this time.
Yes.
Sometimes you've got to unwind the commander a little bit.
This was entry day. You see us wearing the gray underwear that goes under the orange suits. We were inspired. I was inspired to try a little pommel horse routine using the treadmill there. I didn't find this so hard at all. I don't know why it's such a
Wasn't
big
that
deal.
pretty either, Mike? However, the judges did vote and gave
They were
him...
fairly generous.
It's the Zero-G Olympics.
We did want to communicate, particularly to the youth of the country, that we really, space is a fun place. And even though we went through a terrible tragedy several years ago, we still want to communicate that there are some things up there that are unique. We want to really inspire the youngsters to take an interest.
Prior to entry, you've got to get the suits back on again and the seats set up and strapped in. After the luxury of being in a shirt-sleeve environment for 4 days, it's kind of hard for us to crawl back into these things. It hurts just to watch it. But these are the suits that we wore then, both during the launch and during the entry. Turns out to be not much different getting into them on the ground. You can see the pole strapped to the ceiling.
Well, this is a sunset taken out the window before we close the payload bay doors, just to transition into the deorbit and landing phase. It's always beautiful as we fade from bright sunlight to darkness. And this is real time. We crossed the western coast between LA and Santa Barbara. It was a beautiful day at Edwards, and as we have done many times before, came in overhead the Edwards Lake bed and made our 300-mile-an-hour descent to a flare at about 2,000 feet above the earth, and then Dick Covey, the pilot, did what every good pilot should do, and that is lower the landing gear when we ask, and came down to a touchdown at around 190 knots, about 200 miles an hour. The machine was absolutely superb in performance, cleanliness. We had a few system problems that we had backups to, but at touchdown, wheel stop, we could look back on a flight that was, as far as I'm concerned, picture perfect, and could not have been better for the country in getting us back in the manned spaceflight business. Our patch that we love so much, that symbolizes so many things to us.